Rails caching. So here we're going to talk about the caching support in Rails, and then we are going to talk about some of the basic concept of HTTP caching, like a E tag and cache control and rack cache and things like that. And then we're going to talk about view caching, and we probably skip page caching and action caching because those two are in fact deprecated in Rails 4. And so we're going to actually mostly talk about fragment caching, and then SQL caching and cache stores. So caching support in Rails. So in order to do some caching, you have to enable config action controller perform caching to true. This is enabled only for the production environment by default. That makes sense, okay? Because for development and testing environment, we do not want the caching to be involved. So let's talk about HTTP caching, and the first topic is E tag. So before we talk about E tags, so let's talk about three types of HTTP caching. So these are the caches that are present in various locations on the net. Okay, so the browser cache, that is the cache that you have in your browser, and it is maintained by the browser. Okay. And then there is a proxy cache. This proxy cache, sometimes called the shared cache, is maintained by proxy server. So if you are going through your company proxy server, that proxy server might actually cache something. Okay. And the last type of HTTP cache is a gateway cache, and it is sometimes called the proxy, reverse proxy cache. And it is maintained by the server. In this case, your Rails application. Okay, so in fact, Rails comes with what is called the rack cache, and this is actually playing the role of gateway cache. So if you see the picture, let's say we have this client and this client directly connecting to foo.com, which is running Rails application, and these three small clients are connecting through some kind of company proxy server. So all these end clients, okay, these five guys should have a browser cache, right? So because they are using browser, the browser should have a browser cache. However, these three guys, because they are connecting through company proxy server, the proxy server should have shared cache. Okay, so proxy server might actually cache something. And then this is a backend. So backend application in this case is running, Rails application, and this Rails application might cache something. In this case, using rack cache. Okay. Okay, so let's talk about browser cache. By the way, the same data could be maintained in all these three different types of cache. Okay. So how does browser cache work? So browser cache maintains the responses from the server. That makes sense, right? And the browser asks the web server if response to a GET request hasn't changed. So once a response has been cached in the browser will, when the user trying to get the same data, browser will ask the server whether that, the response has been changed or not. If the server says response has not changed, and then browser then get the response from the browser cache. Okay, and the server says this response through this 304 non-modified. This is HTTP response code indicating the fact that that page has not been changed. Okay, so this is indication from the server to the browser that the data has not been changed, meaning response page has not changed. Now, in terms of getting this scheme to work, there are in fact the two schemes, the how browser and server communicate. One is called E tag, and it is actually supported from HTTP 1.1. And then last modified header. This has been supported from HTTP 1.0. Okay. In fact, you see these two are in fact used together. Okay. So how does eTag scheme work? So let's say browser sends a resource request to a Rails application. So when the Rails renders a resource for the first time, it computes MD5 hash from the rendered resource, meaning response page, then inserts this eTag MD5 hash response header in 200 OK response. Okay, so you can think of this MD5 hash as an eTag value. Okay, so we're going to actually try this one in the hands-on lab in a few minutes. Okay, so I just want to actually go over these steps first. Okay, so the server will actually send back this response of 200 OK, and then eTag has a value of MD5 hash of the response. Okay, so browser will cache the response with this MD5 hash. Okay, for subsequent request, browser sends this header, if none match an MD5 hash value that it cached. So it's basically asking the server, whether this MD5 hash version of the response has changed or not. So Rails server will compute MD5 hash again from the response, and if it matches with the one with the browser, so browser will send this guy, and Rails will compute again. If these two guys are matched, then the response page has not changed, right? So in that case, server will send back 304 not modified response header. 304 not modified response status. Okay, and then response body could be empty. Okay, but the body could be still set. Okay, the browser uses the response. So when the browser receives this 304 not modified, then it considers, then it assumes that response has not been changed, so it will get the response from the browser cache. Does that make sense? Let me see whether you guys have any questions. So let's move forward. Yeah, so this is the picture, that captures. So when the request is sent and the response is returned with a 200 OK, and then see eTag here. eTag contains this MD5 hash that was computed by the server here. Okay, so this is the first request and response. Now the subsequent request and response. Okay, what will happen is the browser will send this if none match with the MD5 value that it has received in the previous slide. This value will be used in subsequent request. So subsequent request header will contain if none match. Okay, and then server will send back, if there has not been in fact any change. If there has not been any change, it will send back 304 not modified. Okay, all right. So that's the way things work. So let's do exercise 1.1 and 1.2, which is exactly to see this interaction by capturing the traffic. Okay. All right, so let's take a look at the lab documentation, caching. So here, eTag. So we basically create a brand new application and all that stuff. So basically this is what you are going to see. Okay. Now let's take a look at the. So we're going to actually go to localhost 3000 student 1. So we're going to actually get the data of the first student. Okay. So I'm going to say here, I can just click show or student 1, either one is fine. So before we do that, so I'm going to actually use Chrome, okay, because I like the Chrome, the localhost. Like use the Chrome developer tools, okay. All right, so let me just close all the other tabs, okay. And let's open the developer tools first, okay, and click network. Okay, so we want to capture the request and response traffic, okay, and then click this show. Okay, so now let's take a look at the traffic. So click this guy, and let's see the headers. So headers. So here so basically this is request, and this is the and then we have a response. And key point here is that response should actually contain yeah, I'm going to just slide down. Response should contain e tag with this value. So this is MD5 hash representing response, I mean this page that we are displaying, okay? And this is 200 OK, right? Okay, all right. Now if I refresh this page again, then we are sending the request again, right? So let's click this guy, then we are going to see the second exchange. So that is the second exchange. Now if you take a look at the request header, you see there is if not modified, if non-match, and this is the same value that we have received in the previous exchange. Okay, and if the server thinks that thinks that nothing has been changed, then it should return this status code for not modified. Does that make sense? Okay, so that is basically the exercise I want you to do in ETAG. So 1.2, I think that's basically, yeah, I think, yes, 1.2. So I'll give you guys 5 minutes to try the exercise. Okay, so let's talk about the ETAG with Rails. So we're going to actually take a look at ETAG without any Rails optimization, and then with some Rails optimization. Okay, so here is the case. We are using ETAG with the Rails optimization, and this one without using optimization. So the ETAG itself provides caching capability for the response coming from the server. So no need for the server to send the response body for browser cache resources. But issue with this is this. The Rails will compute this MD5 from the rendered response, meaning the index.html.elb file. The whole thing has to be used to compute, right? So MD5 hash gets computed from the rendered response rather than a model object. But typically what we want to do is that if the model object doesn't get changed, then rest of the page probably doesn't change anyway, right? So it's a lot simpler or faster to compute the MD5 from the model object in question or collection of model object in question rather than computing from the response page itself. Okay, so that is actually something that could be improved. So that's basically what we are talking about here. So we want to be able to compute this MD5 hash from a model object or from a collection of model objects, depending on what page is actually displaying. If the page is displaying collection of objects, then we certainly want to check collection object. And if the page is displaying just a single object, model object, then we want to see if you can create a hash from a single model object. Okay, so it will do. It will result in faster computation of MD5 hash. So this is what Rails could actually provide some optimization. Now, before we move on, let's compare ETAG versus last modified. So, the last modified was supported from HTTP 1.0, and ETAG was supported from HTTP 1.1. However, HTTP 1.1 recommends the server to send both ETAG and last modified response headers. Okay. However, Rails does not set last modified response header by default. Okay, so it sets only ETAG response by default. Okay, I mean there is a way that you can send both, but it probably doesn't make that much difference. Okay, because ETAG is good enough. Okay, so now let's see how we can do optimization in Rails code. So instead of actually computing MD5 hash from the response page, we want to create MD5 from a model object, okay, or collection of model object. Okay, And we also want to be able to set both e-tag and last modified response headers. That's actually something we could do in the API. So that's so Rails actually provided two options. One is a fresh when options. Use it when you want to use the default renderer, and stale. Use it when there is additional logic needed at the controller level in order to render. Okay, so we're gonna actually take a look at so probably not much important here. So we are gonna just use one. Oops. So here we are going to use the stale in the basically the show method, which display a particular student. Okay, what we can do is that we are going to say if stale, and then last modified, meaning we want to return last modified response header, and also e-tag is going to be computed based on student cache key. Okay, and so basically this is for creating MD5 hash from the student object, and this is also for sending back last modified response header. Okay, so if you don't care about the last modified response header, you can just take this out. Okay. All right, so that is exercise 1.3. So let's see 1.3. First of all, you want to actually perform caching true, because we can the caching is enabled. Okay, so you want to change development environment. LB file. So that is config action controller perform caching, and for now, as this is actually set to false for development and testing, so we're going to change it to true. Okay, and then we are going to modify student controller.lb file. And in the case of show, we are going to we're going to add this code. Okay, so basically creating e-tag and last modified. Okay, and we save the changes, and then we need to restart the server because we changed the configuration, right? Okay, so stop it and start it again. Now if we go to student 1, okay, we are going to see status 200 okay, and we are going to see not only e-tag but also last modified. Okay, now the first time you can see X runtime is like in this case 0.4 second the first time. Now the second time when you refresh it, okay, so this is basically refresh the browser. Second time, when you get 3 or 4, you're going to see the X runtime is a lot smaller. Okay, so let's see how that works. So okay, I'm gonna go to Chrome. So refresh the page. Okay, so this is 200, and so take a look at the X runtime. It's actually 0.5 second. Okay, now and also you can see e-tag and last modify, both of them are actually being returned. Okay, so the first time it takes 0.5 seconds. Now if I refresh it, and because things are actually coming from the cache, okay, we should actually see much smaller time period. So in this case 0.001, so it's like a less than 2%, instead of was that 0.5? 0.5, yeah, it was the exchange was 0.5 second. Okay, and now this is actually the 10 milliseconds, so it's like 500 millisecond versus 10 millisecond difference. Okay, so that is that, and this one is in fact the same thing as if stale. Okay, so you can change it and it should actually work the same. Okay. If you want to clear the browser cache, you can do that from here. Okay. In our case, because the MD5 has been recomputed, it's actually starting from scratch, right? Okay. But in case, if you want to actually start again, for now, if you just keep doing it, it's going to actually getting things from the cache, okay? And 3 or 4 non-modified. So if you want to actually manually clear the cache, so you can go to the setting, at least in Chrome, and then click the advanced. Okay, so now as a default, it's hidden, so you should actually click show advanced settings, and then you are going to go the contents. What is the contents? Here we go. Content settings and clear browser data. So here, you can clear cached images and files, and so I'm gonna, clear the cache. Okay, so clear for the past hour. Okay, clear browser data. So the cache is now removed. So now let's try it again. Okay, so refresh. Now it's actually getting things from scratch. Okay, so now we get the 200 OK. Again, the time is 0.01. Oh, wait a minute. Yeah, it seems like it's still getting from, yeah, it's very small amount of time. So, yeah, it's still possible. I mean, the server, it still actually go to the server, and server actually has to actually send it back. Okay, but because it's local server, it might be actually, very small amount of time. But I kind of, kind of surprised that this is actually this small amount. Okay, so that is that. Okay, so I'm going to give you guys about 7 minutes to finish this exercise 1. Next topic is HTTP caching and cache control. So cache control header is introduced in HTTP 1.1. And it basically gives web publishers, meaning on the server-side application, to have more control over their content to address the limitations of HTTP 1.1 expires. Okay, so this is basically cache control header. Okay, so cache control could have must revalidate or private or max age. Okay, yeah, so this is actually, in fact, I think one of the questions I think Robert was asking was, what is the default timeout for the cache, right? This is something that could be actually controlled by the server application, okay, by setting the max age. All right, so let's take a look at each of these values. So when must revalidate is set, the browser should always check the server before it serves up a page from the cache. So HTTP allows caches to serve stale representations under special conditions by specifying this. Yeah, well, the thing is this, the maybe browser detect that there is no internet connection, then it might actually go to the cache anyway to serve it, right? By setting must revalidate, it should never do that. So if you want to make sure, regardless there is internet connection or not, you want to make sure the browser always checked with the server, then you can set this must revalidate. Okay? And private. So private, when you set it private, it caches data. There are some data that is specific to a user, and that data could be in fact sensitive information for the user, right? Now, if you think about the caches, HTTP caches, there are 3 different places. Browser cache, which is considered the private because that's only consumed by the particular user, right? And then we have a proxy server cache as well as the reverse proxy cache. That's actually, if you think about it, that is if you see the picture, this cache, gateway cache. So browser cache is considered private, while this proxy server cache as well as backend cache are considered public. Meaning anybody can actually access those public caches, right? So if this user A, let's say this user B, the data could be actually cached in proxy server here, shared cache, and that's considered public because other users might be able to get it. Okay, so from the application developer standpoint, if you think certain data has to be maintained only in private, okay, that's where you can set this private. Okay, so you can set it private or public, and if you say public, that means data could be cached not only in private but also public caches, meaning gateway caches as well as reverse proxy caches. Okay. All right, and then you can specify max age. So this is the maximum amount of time the representation will be considered fresh. So from a developer standpoint, you want your data to be cached maybe like 130 day, the couple of hours, whatever amounts of time that you think is actually appropriate for your particular application. Okay, and so in that case, the cache for that period in the second period is considered to be fresh. So browser might in fact actually serve that when internet connection is off. Okay. All right. So the way you can set this max age is using expires in method in your action. So when you say expires in 3.minutes, that means you want to set that max timeout to 180 seconds. Okay, so once you do this, and also this is actually setting public. Okay, so things are default. But if you want to actually allow the public, the caches to maintain your data, then you can say public true as well. Okay, so let's do exercise 2. So in this case, you're basically let's see. So we're gonna add this code. Expires in 3 minutes. So let's try that. So here expires in 3 minutes. So we're actually setting the max timeout to 3 minutes. Okay, and now we are going to refresh the browser. So refresh the browser. Okay, and let's take a look at this guy, and you can see the cache control. So this cache control says max age 180 seconds, and it is still private. Okay, so what you want to do is we want to make this guy public. Okay, so this is what we just see. So this time we are going to make this one public. So we're gonna say public the hash value to true. Okay, so we save the change. Now let's try that again. Now if you take a look at the oops. Now if you take a look at the cache control, now it is set to public. Okay. All right. So that is the exercise. Okay. I'm going to continue the presentation to exercise 3 as well, and I'll give you a bit more time. Okay, HTTP cache, rack cache. This is this guy. Oh, sorry. Yeah, this guy in the application. So we are talking about gateway cache. Okay. So gateway cache. So gateway caching for Rails application is done through rack cache. So Rails implementation of reverse proxy cache or gateway cache. Yeah, looks like I have a picture right here. Okay. So it's automatically configured when caching is enabled with config action controller perform caching true. So when you set this one to true, this will be set. And again, this is considered as a public cache. Okay. All right. So let's see how this rack cache works. So suppose we have the Alice is a user number 1, and then we have so this is a backend cache, okay, and this is your the Rails application, okay. So the first time Alice is asking for some page, like a welcome page, cache doesn't have it. This backend cache doesn't have it, so it's going to get the the page from your Rails application backend, okay. So it will return hello world here, and let's say the max age says to 600 seconds, and then this backend cache will be saving it in its backend cache, okay. Now during that 600 second period, there is another user, this time Bob. So Bob will actually go to the same page and to the same backend cache. So since backend cache has that the welcome page in its own cache, it will send back the response directly, and it doesn't have to go to the backend Rails application. Okay, so that's basically what rack cache is working. Okay, so exercise 3 is a rack cache. So here, by the way, we have to actually install the rack cache gem. I think my slide so my slide is incorrect in Rails 4. So I should actually change. I believe. Yeah, this one is incorrect in Rails 4, so I should actually change slide 25 caching. Yeah, so in order to enable rack cache, you have to actually use a gem, okay, in Rails 4. Oops, sorry about that. Okay, so I was looking at the documentation. So we are going to install the rack cache gem. So you have to add this. So so we're going to actually do production environment, okay. So we are going to change gem file, and I'm going to just add it here, okay, rack cache, and then we are going to bundle install. And then we are going to modify production environment. So we are going to rack cache. Then once the gem is installed, we have to actually set this guy as well. So we are going to go to production RB file, and we are going to see config action controller. This guy. Yeah. So we are going to the uncomment config dispatch rack cache true. Okay, so rack cache is now enabled. Okay, all right, so we did that, and then we're gonna actually start the production. So we're gonna actually stop it, and we're gonna start the we're gonna actually migrate. You mean for production environment? Okay, so we have to create the tables for production environment. And we are going to also perform db seed for production environment as well. And then we're going to start the production server. So let's start the web server with production environment. Okay, so now let's go to the first student, and now we're gonna actually see what's happening here. You can see, you should be able to see now X rack cache. Okay, so let's take a look at this guy. So we will actually start from scratch. Okay, and 12 and network. Now I'm going to go the first student. Yeah, so I have to change this guy to security. Config secret. I'm gonna just copy this guy and this guy and production. Save the change. Okay, and we'll start it again. Okay, so we are going to and we'll try again. Okay, now if you take a look at this guy, you are going to see the extract cache miss, ignore, and store. So basically what it means is that the first time the client is trying to get this record number 1, student 1, it's not there. It wasn't in rack cache. Okay, I guess I don't know what this ignore is all about, but it's going to store that data in the rack cache. So what's important is miss and store. Okay, all right. So that is the first activity. Now, if you access the this the same location using a different browser. Okay, so I might actually do that in Firefox. So I'm going to actually do that here. Okay, I'm going to F12, and this is Firefox. So I'm going to capture the network as well. What's that? Clear HTML. Man, it's been a while since I used this guy. Okay, so I'm gonna just see the documentation. Okay, so okay, so this is the so I'm going to explain this one first. Assuming you are using a different browser, so suppose this is actually a Firefox, the other one is the Chrome, and then what you're going to see is a fresh, meaning it's actually getting the data from the rack cache. Okay, and then wait for, now we are going to actually see 3 minutes. Okay, now the cache will be cache will be expiring in all caches. Okay, so the rack cache is going to be expired. Okay, so wait 3 minutes, and then if you try to access it again, and you can see the data in the rack cache is stale as invalid, and it's going to store again. So brand new response will be stored again. Okay, so that's basically what's happening. All right, so I'm going to give you guys about the 7 minutes to do this exercise 3. Okay. Next, we are going to talk about action. We want to talk about the page caching first. Okay, so we're going to talk about 2 caching schemes that are actually deprecated. Used to be part of the Rails core, but they are removed, in fact deprecated. They are called the page caching and action caching. So I'm going to just explain what those things are, and then we're going to actually move forward. So page caching is supposed to be most efficient forms of caching in a Rails application. So basically, once a page is cached, the future requests don't need to hit the application at all, as the entire content of the page is cached into a file in the public directory, which is then served by a front-end web server. So, controller doesn't even get involved, and nothing will be logged. However, it gets deprecated in Rails 4 because the manual expiration handling of this page cache is considered too cumbersome. The page caching is actually efficient, but how we expire these pages have been actually done. It has to be done manually, and it wasn't really good to do those manual expirations, so it was actually removed. So if you want to use page caching, you can still using action pack page caching gem. Okay, so let's see how that works. So suppose you say you're going to say caches page and index and show. So what that means is that once you've done that, and once this index and show pages are accessed, then what happens is that these pages, these pages are going to be student 1 and student 2. So if the student 1 has been accessed and student 2 has been accessed, those responses will be maintained on the public students. So these are pages that are cached. Okay? And these are students. If the students have been accessed, the students.xhtml student HTML file is in fact cached. Okay? So how do you expire page cache? So you have to manually expire page. So whenever student is modified, like a student 1 is updated, that's the time you are going to in fact expire this page cache, okay, by using the expire method. So this is a manual cache that we are talking about. So there is actually a scheme for using sweeper. So basically instead of scattering the same expire page method throughout the controller, it's better to move the code into a sweeper. So sweepers are terminators of caching and responsible for expiring caches when model object change. Okay, so even with the sweeper, however, it was actually pretty cumbersome to make sure that caches are in fact expired. Okay, so that's the reason page caching was removed. Same deal with the action caching. So action caching, the difference between action caching and page caching is page caching cannot be used for actions that have a before filters. For example, if you want to make sure a user is authenticated through the before filter, if page caching is used, then page caching is going to be just to serve without even going through this before filter, right? So that's where this action caching comes in. So action caching is going to make sure the before filter gets executed before the page is served. Okay. Anyway, so this page caching and action cachings are deprecated. So we're going to just move forward. The last one is what is called the fragment caching. So fragment caching is done at the template level. So what you need in many cases, what you want to cache is the fragment of the page rather than the whole page. Okay. Especially the web application, it build pages from many different sources, right? So it's quite common to see a certain fragment stay the same, but other part of the page changes. So in that case, you want to cache only the fragment that remain the same. For example, suppose if you have a blog application, so if you have a page that displays the blog and the related comments, whenever a comment is added, you might want to actually change the comment page, but the block itself, that fragment, does not have to change. So block fragment could be cached. Same deal here. When you have a page that display the product and that display all the products and orders, right? The orders might be changing, but the product's information doesn't have to be changed, right? So in that case, a product fragment could be cached. So how do you actually fragment caching? So the way you do fragment caching is you do within the view. So here, if you want to cache this guy, all right, so this is a case that the orders will change if the order actually, has been, if the user has added an item or things like that. But the product information doesn't have to be changed. So that could be cached. So what you can do is we can say cache, and we can give a name, like all available products, okay, and then we can actually expire this fragment providing this fragment name. So this fragment will be cached. Okay. All right, so let's do fragment caching exercise. Before we do that, let me explain the SQL caching. So SQL caching is for, the Rails could actually maintain the result of SQL result in a cache. Okay. And that's SQL caching, and the cache stores could be memory cache, file cache, mem cache, or eCache. Okay, so you have schemes in terms of what you can choose. All right, so let's take a look at the fragment caching. So I'm gonna go to fragment caching. So if you have done the exercise 4 and 5, you want to remove those page caching. Since we haven't done anything, we don't have to do this exercise 6.0. So we're gonna actually just move on to fragment caching. So here what we are going to do is we want to, the number of students, okay? So we want to display number of students, okay? So we're going to add this guy, So this number of students are not going to change unless you add new student or destroy new student, right? Destroy existing student, right? So here we are going to, yeah, I'm going to just explain the code, and then I'll let you guys do the exercise. So basically, we are going to cache this guy, number of students, and the student size. And so we display the page, and we see number of students is 3, okay? And you can see, in fact, development loop that is reading the fragment for the first time, okay? And then we display, then we're going to actually destroy one of the students, okay? And then, you know, the, yeah, so it should be, yeah, it looks like this one and this one is captured different times. So let's say we are going to actually destroy a student, okay? And the number of student is still 4, and that's not good, right? Okay, so this is because we have not flushed the fragment cache. So we are going to add fragment cache flushing logic in the next step. So what we can do is now we are going to say the my fragment, and then, you know, for now, for the sake of testing, we are going to actually the skip digesting, meaning creating MD5 MD5 hash, okay? So we are going to actually say my fragment, and then we are going to, whenever student is added or removed, we are going to actually expire fragment. Okay, so that's the time the fragment will be expired. Okay, now so that should work fine. Now, you know, the in general, in the Rails 4 has improved the caching. They use what is called the Russian doll, caching. You know, in a sense, the cache will be expired automatically based on this hash. So whenever contents are changed, the name of the cache will be changed. So that's the way that it figures out that, you know, things change, and it will automatically flush the cache. So instead of actually you do manual caching expiration like this, this is just for the experimentation. In Rails 4, things are a lot more automatic. Okay, all right. And so in order to actually kind of do this exercise, you know, we actually do skip digest, meaning we are not going to actually generate that MD5 hash. Okay. All right. You know what? I'm going to actually move forward to the new presentation. So let me just save this guy, since we have only 25 minutes.